we're going to calculate the surface integral of the above function over 5 sides of this cubical box which has a side 2. And what we do is we're going to look at each side in turn. So we start off with the first side, which is side 1. Now what can we say about side 1? Well, we can say that x is equal to 2. Now x is constant, but the y and the z changes, so our infinitesimal displacement area is equal to dy dz x hat, since x hat is perpendicular to that surface. So now what we'll do is we're going to take our dot product of our vector v with infinitesimal displacement area. And remember, x hat dot x hat is equal to 1, x hat dot y hat is equal to 0, and so on. So what we obtain here is 2x z dy dz. And what we must do is integrate this over the surface for y going from 0 to 2 and z going from 0 to 2 as well. So here we have the integral of v dot dA is going to be equal to, we can substitute 2 in for x, so you got the double integral from 0 to 2, from 0 to 2 of 4 z dy dz. Now when we work this out, what we will get, if we take the integral with respect to y first of all, we're going to get 4 yz dz, so that will equal to the integral of 8 z dz, so 0 and 2. Now we take the integral with respect to z, so we're going to have 8z squared over 2, which will result in 16. So that's for our first side. Now what about our second side? Now our second side is at the back, and on the second side x is equal to 0, and we have our infinitesimal displacement area dA is equal to minus, because it's in the other direction now, dy dz x hat. Taking v dot dA will be equal to minus 2x z dy dz, which is going to be equal to 0. So it's equal to 0 since x is equal to 0. Now, let's look at our third side. On our third side, y is constant at 2. So you have y is equal to 2. And our infinitesimal displacement area, dA, is equal to dx dz y hat. Okay, so y hat, of course, is a unit vector which is perpendicular to that surface which we're integrating over. So now we take our dot product, or v dot dA is going to be equal to x plus 2 dx dz. Now again, what we must do is we must integrate over x and z. So we have the integral of v dot dA be equal to the double integral from 0 to 2, 0 to 2 of x plus 2 dx dz. And when we integrate this out with respect to x, we will have x squared over 2 plus 2x. So x squared plus 2 over 2x, we put in for 2. This is going to give us 2 plus 4, so it's going to give us 6 dz. Now we integrate this, we're going to get 6z, so we get 12. So this is our answer for our third side. So as you can see here now, there's a bit of repetition. And we're just doing the exact same thing for each side. So now, what about the fourth side? Now, so for the fourth side, it's similar to what we just did for the third side, except it's going to be a negative in there for the infinitesimal displacement area, and also y is equal to 0. So we have y is equal to 0, and the infinitesimal displacement area dA is equal to minus dx dz y hat. So we worked through in a similar way what we did for the third side, and what we're going to find is that the integral will be equal to minus 12. So now we come to the fifth side. So if we look at the fifth side again, for the fifth side, we're on top, we have z is equal to 2, and our infinitesimal displacement area is going to be dx dy z hat. So here we have z is equal to 2, and our infinitesimal displacement area is equal to dx dy z hat. So now we take v dot dA of this, and what we get is what we're going to get here is y by z squared minus 3. So we have y by z squared minus 3 dx dy. So z is equal to 2, so this is going to be 2, 4, this is going to be y dx dy. So now we come to it again. What we must do is we integrate v dot dA from 0 to 2, from 0 to 2 for y dx dy. So we do x first. We're going to get xy, so we're going to have, between 0 and 2, we have 2y dy, which is going to be equal to, you get y squared over 2, so we're left with 4. So now, what is our solution? Well, what we must do is must add up all the parts. So we have 16 plus 0 plus 12, so 28. Plus minus 12, so back down to 16. And 16 plus 4. So here we go, and our answer is 20.